In this video, we're going to discuss a worksheet on transfer of thermal energy. You can get this worksheet on our website. The link is in the description below. Question 1. A copper rod is heated at one end. Which statement describes how heat transfer occurs in copper? A. Energetic copper molecules move from cooler end to hotter end. Energetic copper molecules move. Energetic copper molecules do not move. So A and B both are wrong. Molecules stay in their position. So when a copper rod is heated, heat is transferred from this region. Let's say it's heated at this end, so heat will flow from this region to this region, but the molecules will stay in their place. Energetic free electrons move. Free electrons move from a region of higher heat to a region of lower heat. So energetic free electrons move from a region of hotter end to the cooler end. So in a metal, heat is transferred in two ways: by free electron diffusion and by vibration of molecules. But molecules stay in their position. Molecules vibrate and collide with the neighboring molecules, transferring heat. And free electrons get kinetic energy and they start to vibrate, and when they collide with another atom, it gives off the kinetic energy to that atom, which in turn vibrates again, and that's how the heat is transferred from a hotter region to a colder region. So the answer is D. Question 2. Which heat transfer process do not require a medium? So radiation is the only process that does not require medium. Conduction requires a medium. Conduction requires a metal or a conducting material. Convection requires fluids to occur, but radiation is the only method that doesn't require any sort of medium. So our answer is C. Sun's heat is traveled from the sun to the earth, and there's vacuum between the sun and earth, but still the energy flows from the sun to earth by radiation, which does not require any sort of medium. Question 3. Which description of a dull black surface is correct? So black surfaces are good emitters and absorbers of heat. So they're both good emitters and also good absorbers, but they are poor reflector of radiation. White surfaces or shiny surfaces. A dull surface is a bad reflector of heat, but a shiny surface is a good reflector of heat. So it's a poor reflector of radiation. So it's C. Question 4. The diagram shows a glass tube filled with water and suspended above a bench. The water is free to circulate around the tube. At point P, there is a convection current moving downwards direction, at which point is the tube heated to cause this convectional current. Water must be heated at the bottom to create a convectional current, because if water is heated at the bottom, it will expand and will rise up and create a convectional current. So option A and D are the bottom level. And we can see the water is moving downwards, which means the convectional current is something like this, in a clockwise rotation. So if water is heated at this end, this water molecule, the water molecules present in this region will expand, will get less dense and start to rise up. And in this region, the cooler molecules will move downwards, which is shown by this arrow. Water molecules will move downwards and will create a convectional current in this direction. So A is the answer. Question 5. 4 metal containers with identical dimensions are filled with water at 90 degrees Celsius. All the faces except one of each container are covered with a very good insulator. The one exposed face on each container is painted either black or white. In which container does the water cool the fastest? So black surfaces are good radiators of heat. So the one painted black will lose the heat at a faster rate, not white, because white is a good reflector of heat, not radiators. So black are the ones that will get cooled the fastest, and a small face painted black and a large face painted black. So our large face painted black will have a larger surface area. So the larger the surface area, the more heat is lost by radiation. So the answer is A. Because if the face is small, the surface area will be small and less heat will be radiated from a small surface. Let's move on to question number 6. Which statement is correct? Infrared radiation cannot travel in vacuum. Infrared radiation cannot travel in solids or in gases. Infrared radiation can only travel in a vacuum. Infrared radiation can travel in vacuum and gases. So infrared radiation can travel in vacuum because it's an electromagnetic spectrum and it does not require any medium to travel. So A is wrong. Infrared radiation cannot travel in solids and gases. It can definitely travel. Electromagnetic spectrum can penetrate any solids or gases. So B is also wrong. Infrared radiation can only travel in vacuum. It can also travel in solids and gases such as electromagnetic spectrum such as microwave or radio waves, so can travel in air. So can infrared radiation because it's also an electromagnetic spectrum. So C is also wrong. D says that infrared radiation can travel in vacuum and also in gases. It's correct. Infrared radiation and all electromagnetic radiation can travel both in vacuum and also in gases because any medium is not needed for them to travel. Question number 7. A glass beaker contains water in a warm room. The water is initially at the same temperature as the room, which change will not affect the initial rate of evaporation. So the rate of evaporation. So rate of evaporation is affected by temperature and surface area it's exposed to. In option A, change in the temperature of water. So if the temperature is increased, the water molecules will gain more kinetic energy and more water will be lost from the surface. In option C, using a beaker with a larger cross-section area will increase the surface area of water exposed to air, which will also increase the rate of evaporation. Using a fan to blow air over the beaker will increase the rate of evaporation because as more air is blown over the surface, the air will take away the water molecules from the surface. So it also affects the rate of evaporation. So does C and also A. But B, using a beaker made of thicker glass, it will not affect the rate of evaporation because a beaker with thicker glass will make the water conduct less. So we're dealing with conduction, not evaporation. So answer is B. Let's move on to question number 8. A student makes 4 statements about evaporation and boiling. 1. Both involve an increase in molecular separation. It does. Evaporation is the escaping of energetic molecules, and molecules separate from other molecules. So 1 does. Both occur only at a fixed temperature. No, boiling only occurs at a fixed temperature, but evaporation can occur at any temperature. Both involve the absorption of thermal energy. Yes, both evaporation and boiling will definitely require thermal energy, so it's also correct. Both occur throughout the liquid. Evaporation occurs at the surface of the liquid, so it's also wrong. Boiling occurs throughout the liquid, so number 1 and 3 are correct. So the answer is C. Number 9. What is described as the escape of more energetic molecules from the surface of liquid? So evaporation is the answer because evaporation is the escaping of more energetic molecules from the surface of the liquid, which is described by this statement. So in a liquid, energy is not equally distributed. Some molecules will have a very high amount of energy compared to the others. Molecules which have the highest energy escape from the surface of the water or the surface of the liquid, which is evaporation. Let's move on to question 10. When a piece of smoldering rope is held at the opening of the box in the diagram, smoke moves in the direction indicated. So the smoke moves downwards, then it moves on the right hand side, then it moves upward. What is responsible for the movement of the smoke? When the candle is burning, the hot air, it rises up, and the cold air from the environment, it sinks down and enters through this region. And this causes a convectional current. And when the smoke is placed here, when the smoldering rope is placed here, the smoke gets trapped in this convectional current and moves in this direction. So the convection is the reason that causes the smoke to move in this way. So our answer is A. Let's move on to question number 11. The diagram shows four identical cans with their outside surfaces either polished silver or painted black dull. Each can each can contains the same volume of water initially at 80 degrees Celsius. After 5 minutes in a cool room, which can contains the coolest water? So black surfaces, especially dull black surfaces, are good radiators of heat, and heat is radiated out so the water cools down. So dull black surfaces are the ones that loses the water by radiation the fastest. And if the can is covered with a lid, the water molecules cannot escape. The energetic water molecules cannot escape by evaporation. So in option C, the energetic molecules cannot evaporate. So the water will not cool the fastest. But in option A, water molecules can both move out by evaporation and heat is also lost by radiation. So in option A, the water in the beaker will lose the heat the fastest. So A is our option. Question number 12. Samples of four different materials at room temperature are heated from below and heat is transferred upwards. In which material is all the heat transferred by vibration of molecules? So heat is transferred by vibration of molecules by the process known as conduction. So air, mercury, and water are fluids, and heat is transferred in fluids by convection, not conduction. So air is wrong, mercury is a fluid, is also wrong, and water is also wrong because it's also a fluid. And mercury is a metal that's liquid at room temperature. So rubber is our answer. Rubber is an insulator of heat, but it is solid at room temperature, and solids only conduct heat by conduction. So answer of 12 is C. Question 13. A metal lid fits tightly on a glass jar. Which process makes it easier to remove the lid from the jar? So if it's a lid which is tightly attached to a jar, cool the lid only. So if the lid is cooled, it will shrink and it will attach to the jar more tightly. So it's also wrong. Put the jar and the lid in the refrigerator. It will also cool the lid in the jar, so it will also make it more tighter. It will not make it easier to remove. Warm the jar only. So warming the jar will make the jar expand, because when anything is warmed or heated, the distance between molecules increases and that particular object expands. So warm the jar only will only expand the jar, not the lid. We need to expand the lid. So warm the lid only will make the lid expand, and as it expands, it will be easier to open the lid. So as it's heated, the lid will expand and it will become more easier to open the lid. So D is the answer. Question number 14. A cold bottle containing a drink is placed on a table on a warm day. Drops of water form on the outside of the bottle. Which process causes the drop to form? So when a bottle is placed in a table on a warm day, drops of water forms on the surface of the bottle. So if the bottle is cold, the water molecules present in the environment, in the atmosphere, will condense on the surface of the bottle, and this is the reason which causes the drops to form. So condensation is the answer, because when molecules condense, they get closer together because the temperature is lower. As the temperature lowers, the molecule gets closer together and it condenses. So here, the moisture in the air condenses because of a drop in temperature, which is because the water bottle is cold. The surface of the bottle is cold, which makes the molecules surround, which make the water molecules surrounding the bottle to condense and form drops of water on the surface of the bottle. So condensation is the answer. Conduction is a process where heat is lost. Convection is a process where heat is transferred, and evaporation is also a process where more energetic molecules are lost. So condensation is the answer. Question number 15. Four beakers contain equal volumes of water at two different temperatures. The beakers are placed in open air. From which beaker does water evaporate the fastest? So Evaporation is affected by two conditions. One is temperature and the other one is surface area. The higher the surface area and the higher the temperature, the faster the molecules evaporate. So the surface area should be high and the temperature of the water should also be the highest. So answer is D. Let's move on to question 16. A metal box has four different surfaces: dull black, shiny black, dull silver, and shiny silver. The box is filled with boiling water so that each surface is at the same temperature. A sensor measures the amount of radiation from each surface. So dull surfaces are dull black surfaces are better radiators of heat. So which surface emits the least radiation and which surface emits the most radiation? So dull black surfaces emits the most radiation and the least should be shiny silver surfaces. So this should be shiny silver surfaces and the most should be dull black surfaces. The answer is D. You need to remember that dull black surfaces are the best radiators and absorbers of heat, and shiny surfaces are the best reflectors of heat. So in this question number 16, the least radiating surface is shiny silver because they reflect the most, and the most radiating surfaces are dull black because dull black surfaces radiates the heats the most. Question 17. Scientists believe that some lakes are shrinking because of evaporation. What increases the rate of evaporation? So an increase in temperature or an increase in the surface area increases the rate of evaporation. A decrease in surface area will decrease the rate of evaporation because surface area is directly proportional to the rate of evaporation. A fall in water temperature, a fall in temperature will not increase the rate of evaporation. The molecules will have less kinetic energy. An increase in the depth of the lake. So depth of lake has nothing to do with the rate of evaporation. The surface area of water, if it increases the rate of evaporation, and if the temperature of the water increases, the rate increases. And the last thing is wind blowing across the surface. So this is the answer because as more wind blows, the water molecules are carried away from the surface, so it increases the rate of evaporation. So as the more wind blows, the water molecules that are on the surface, they are blown away, and the rate of evaporation increases. So our answer is D. Question 18. A dish of liquid is left on a laboratory bench. Some of the liquid evaporates. What happens and why? The liquid cools, the liquid warms. So imagine a cup of tea left on a table. The cup of tea does not get warmer with time. It gets cooler with time because the heat from the tea, it flows out of the cup. So the liquid does not get warm because if a fluid is kept in a table, it does not get warmer with time. It cools down. The liquid cools because liquid molecules have more potential energy than gas molecules. So cooling of liquid molecules that have nothing to do with potential energy. It has something to do with kinetic energy. The faster moving molecules escape. So faster moving molecules have more kinetic energy, and that's why they move from the surface to the liquid, or evaporation takes place. That's why the liquid evaporates. So our answer would be B. Question 19. Which statement about thermal radiation is correct? In vacuum, thermal radiation travels at the speed of light. Yes, radiation travels at the speed of light, such as infrared radiation. It is an electromagnetic wave, and electromagnetic waves all travel at the speed of light. Thermal radiation is a longitudinal wave. It's not a wave. B. Thermal radiation is a longitudinal wave. No, electromagnetic waves are transverse waves, so it's not longitudinal. Thermal radiation travels as an ultraviolet wave. So no, they travel as infrared radiation, not ultraviolet radiation. White surfaces are better emitters, so white surfaces are better reflectors of heat, not emitters of heat. So B, C, D are wrong, and A is the answer. Question 20. A slice of bread is placed under a red-hot electric grill to make toast. how does the heat energy reach the bread? So we can see the grill is not attached with a slice of bread. So as there is no direct connection, conduction cannot take place. But convection can take place because the hot air that's rising, it can create a convectional current, and the heat can be transferred by convection from the grill to the slice of bread. So convection can take place. And another process is radiation, which does not require any medium or is not affected by anything. It can the grill can radiate infrared radiation, and it can travel to the slice of bread. So convection and radiation is the only process by which heat can transfer from the grill to the slice of bread. So C is the answer. Question 21. The diagram shows the inside of a refrigerator. When the refrigerator is switched on, what happens to the air near the cooling unit? So the particles of this air either become smaller or move close together. So particles, the size of the particles never changes no matter how much you heat it, no matter how much you cool it. The density the density of this air will definitely decrease because if the air is cooled or colder air, they're more dense than warm air. So the density of this air decreases as the molecules move close together. So C is the only option that shows us this change. Moving on to question 22. Which statement about transfer of thermal energy is correct? Transfer by radiation does not require a medium. It's true. Radiation can travel in vacuum, such as heat emitted by sun. It travels to Earth by radiation. Transfer is from a region of lower temperature to a region of higher temperature. Heat always flows from a region of higher temperature to low temperature. But option B shows that it flows from a region of lower temperature to higher temperature, which is not possible. So B is also wrong. In option C, transfer upwards in fluids mainly through the vibration of neighboring particles. In fluids, heat is always conducted, heat is always transferred by convection, not conduction. Although a few percentage of heat can even conduct or move by conduction, but it mainly moves or it mainly travels by convection. So it's also wrong. Transfers in solids by means of density changes in material. No, this is convection, or in how heat transfers or flows in fluids. So in fluids, heat transfers by convection or by density changes. So this process of transferring of heat is in fluids, not solids, and this process of transferring heat is in solids, not fluids. So C and D are wrong. The A is the only option left. Question 23. A solid bar is heated at one end. How is thermal energy transferred to the other end? So in solids, thermal energy is always transferred by conduction. So it's by conduction. So we need to search for the perfect definition of conduction. In option A, heated molecules move along the bar. Heated molecules move along the bar. So molecules do not move while heat is being transferred by conduction. Molecules stay in their position. They basically vibrate and hit the molecule to the next and transfer heat. So heated molecules stay completely still. They do stay in their position, but not completely still. Heated molecules vibrate more rapidly and pass energy to the next molecule. This is a perfect definition of conduction. The molecules vibrate but stay in their position and hit the neighboring molecules and transfer heat from one region to another region. So 23 is D. Moving on to question 24. The tubes inside solar heating panels use the sun's radiation to warm water. Why are the tubes painted black? So we need to know one thing is that black surfaces are good absorbers of thermal radiation. In option A, black surfaces absorb radiation well, which is correct. Black surfaces conduct heat well. Conduction is not related with the color, so it's wrong. C. Black surfaces emit radiation well. Surfaces do not emit radiation. Black surfaces radiate radiation well. So one thing is radiation and the other thing is emission. Hot surfaces emit radiation well, but black surfaces radiate heat well. So in order for them to radiate heat, they need to get themselves heated first. So radiation and emission are completely different things. Black surfaces reflect radiation well. It's completely wrong because shiny white surfaces reflect radiation well. So option A is the correct option. Moving on to question 25. A piece of paper torn out of an exercise book is shown. Which process is being described? So, and some of the particles at the surface gain so much kinetic energy that they break free and take the energy away with them. So, evaporation is being described in this paragraph or in these sentences because evaporation is the escaping of higher of molecules with the highest kinetic energy from the surface of a liquid. So some of the particles at the surface of the liquid gain so much kinetic energy that they break free and take energy with them. So particles on the surface of the liquid, they gain kinetic energy because they gain heat, and the kinetic energy of those molecules increases and they break free from the water molecules and escape, taking away that kinetic energy. So it's evaporation. Question 26. An electric heater is placed in a beaker of cold oil as shown. The heater is switched on. What happens to the liquid at X, or the liquid on the top of the heater? So the molecules, the liquid molecules that surrounds the heater, they get warmed up and they rise because their density decreases as they get warmed up. Cold liquid on the top surface, which are not heated, they sink because they are denser, and a convectional current is set up that transfers the heat energy in the whole liquid. So liquid in the position X, it becomes less dense and rises. Question 27. The diagram shows a frozen pond with a surface of ice slowly melting as heat is transferred from the warmer air above it, by which process is heat transferred from the air to the ice. You might think it as convection because in question they're telling that heat is transferred from air, but there's one thing to remember, that convection only happens within the fluid. Convection can never happen from the fluid to a solid. So convection is a wrong choice. If it were convection, the heat would transfer within the fluid. There are some air molecules in contact with the ice, and those air molecules in contact with the ice transfers the heat to the ice, or the molecules collide with the surface of ice and transfer thermal energy. So it's by conduction, not convection, because convection happens within the fluid. The warmer air would would create a convectional current on the fluid above and heat the air above the ice. But the warmer air can never transfer heat to the solid ice by convection because the solid ice cannot create a convectional current within it. So convection is a wrong choice. So conduction or radiation is the answer. The heat energy can radiate from air on the surface of ice by electromagnetic radiation. So radiation is possible and conduction is definitely possible because the molecules in air with high kinetic energy can collide with the surface of ice and transfer its heat. So D is the answer. Moving on to question 28. A glass beaker contains water. When the center of the mass of the base of the beaker is heated, a convection current is set up. Which statement explains this? So convection current happens because the density changes. The water molecules in the bottom, they get heated up they get heated up and the density decreases, and they move or they float, and the colder fluid, it sinks to the bottom, and that's how a conventional current is set up. So in option A, it's the evaporation of water causes water molecules to rise to the surface. It's not evaporation, because evaporation is a completely separate mechanism of escaping of water molecules from the surface. The expansion of water molecules do not expand, so expansion is wrong. The water above the heat source rises because it becomes less dense. Option C, the water above the heat source rises. It's true, because it becomes less dense. The water above the heat source, the water in this region, they rise because they gain temperature from the heat source, and their density decreases, becomes less dense. In option D, the water rises, water at the sides sink become because it becomes less dense. It's wrong, because not on the sides. The water in the region above, they sink because the density is higher. So it's also wrong. C is the option. Question 29. Two identical metal plates are painted, one matte dull white and the other matte black. These are placed at equal distances from a radiant heater as shown. The heater is turned on for 5 minutes. Which metal plate absorbs more energy and emits more energy in this time? So we know that black surfaces are the best radiators and absorbers of heat. So absorbs more should be black, and also emits more should be black. White surfaces are good reflectors of heat, so options containing white are wrong. A is the only answer. Take 2, question 30. Question 30. On a cold afternoon, a house loses 54 megajoule of thermal energy to its surrounding as shown. The heating system must supply more than 54 megajoule of thermal energy to keep the temperature of the house constant. Which statement explains this? The extra thermal energy is lost from the house to the surroundings by other means. The extra thermal energy keeps the house warmer than the surroundings. The temperature of the surroundings decreases continuously during the period. The thermal insulation of the roof is extremely ineffective. The extra thermal energy keeps the house warmer than the surroundings. But in the question, it's told that we need to keep the temperature of the house constant, not make it warm, so B is wrong. In option C, the temperature of the surroundings decreases continuously during this period. The heating system providing more heat has nothing to do with the temperature on the surroundings, because they're not related anyhow. It's also wrong. The thermal insulation of the roof is extremely ineffective. It does not actually tell why we need to provide more than 54 megajoules of energy, so it's also wrong. It's telling that the roof is ineffective because it might tell that most of the energy is lost from the roof, but not why we need to provide extra thermal energy. In option A, the extra thermal energy is lost from the house to the surroundings by other means. It is the answer, because there might be other possible ways the roof might lose energy, which is not mentioned in the question. So A is correct.